In this lecture, I want to do a couple of practice problems about flowcharts and algorithms. We've done a lecture on flowcharts already. The important thing to realize is how important flowcharts and thinking about your algorithms are, because the worst thing you can do as a programmer is to just start typing your program. You need to plan, and you need to plan this carefully. So in this lecture, what I would like to do is I would like to go through a couple of problems, and we can work through a couple of algorithms together and express them using a flowchart. And the great thing about flowcharts, as I've explained before, is that you can follow them and you can get the picture right away. So even if you're talking to a client of yours, if you express the process of your program through a flowchart, even if they don't have any experience in programming, they can get that right away, and they can know what you're actually trying to do for them. So let's look at this example that I have at the end of my slides. Let's say we have a rectangular lot, and we're going to have a circular roundabout in the middle of that lot. And the problem is we would like to find out what is the remainder of what is the remaining area after putting the roundabout in the lot. So a couple of important things. First of all, the assumptions is that the lot is always rectangular, and that the circle is always within the rectangular lot. So half the circle is not out of the lot. So these two, we can assume that. And assuming this is pretty much our algorithm. So first of all, you prompt the user for dimensions of a rectangle. Then you would prompt the user to enter the radius of the circle. So that's your input. You would calculate, and this is your processing. This is your calculations. You would calculate the area of the rectangle, calculate the area of the circle, and then calculate the remaining area. And one step that should be here is you need to display the results. So let's try to express this using a flowchart, and maybe follow along with me. That would be great if you had a pen and paper handy and you could do this with me. So we're going to start our flowchart. Then, because it's an input and output, it's for input and output, we use a parallelogram. So we're just going to say get width W of rectangle so it's another input and output. We're going to say get length L of rectangle. Then get radius R of circle. Now we are actually going to do some calculations. So we're going to say area, so A of rectangle equals W times L. Then we're going to have area of circle equals pi r squared. Then I'm just going to say area equals area of rectangle minus area of circle. And last but not least, we're going to say display area. So notice that this is also a parallelogram. And then at the end, we mustn't forget to put the end symbol there to signify that we're now at the end of the program. And this is something that anybody can follow and go through with. Now, as you can see, there's no decisions to make here. There are no choices. So let's do another example. So let's do an example of a cash register. So imagine you're working at you've been hired to write a program for a department store, and they say if a customer wants to pay, if the bill is greater than $50, so if amount is greater than $50, you are to give them 10% off, and then show the total of the amount. So let's just say start. So it's going to be pretty simple. You would say get amount A, and then here we have a decision to make, so we'll put a diamond, and we're going to say if A is greater than 50, if yes, you'll do some calculations, meaning you would say A equals A times 0.9. So that means you're giving them 10% off. And if no, you're going to display A, and you would display A, and you're done. So it's pretty simple. It's just you have to make sure it's quite logical. Anytime you have input and output, you need to show that using a parallelogram, so it's very clear what's happening. So here, this is used for I/O. This is used for I/O. This is doing math or some sort of a process, some sort of computation, and this is for decision making. So there's going to be problems like this in your studio project. Make sure you work on them, and also ask me or one of the TAs if you have any questions. Thank you very much.